to learn about the multi-layer perceptrons using TensorFlow. So TensorFlow, unlike other open source platforms, so this is a new type of open source platform for machine learning, and it's created by Google, and it's more appropriate for deep learning. So what does it mean by deep learning? In the machine learning, you were basically in my past videos, if you have seen, in machine learning we were mostly taking a data set into consideration, and we assume that there are not that many multiple layers in between the input and the output. But let's say in the neural network we have multiple layers, so in that case we need to apply deep learning, and for deep learning purpose the TensorFlow is more appropriate. It basically supports the complex architectures, and any structure having multiple layers in it. And again, in the same way, we are going to use the scikit-learn library. And TensorFlow also supports training on multiple computers, and use of graphical processing units, which is able to process multiple blocks of data parallelly or at a certain point of time. And TensorFlow is the most preferred platform in case of deep learning and or in case of neural networks, mostly in case of neural networks with multiple layers. So for deep learning in our neural networks using TensorFlow, there are multiple steps that we need to follow. So first we need to scale the data, then need to build the model. So we need to build the model using the sequential function, and the sequential function can create the model and specify or assign it to a model object. Then we will be able to add the layers into model using the model.add, and we will see that in one of the examples. So to add a dense layer or a convolutional layer, so there are two different types of layer we will be able to add through the model.add. Then we need to compile the model. Dot compile is used. Then to train the model, like our machine learning, we will be using dot fit, model.fit. Then in order to evaluate, dot evaluate, or for predictions or to measure the performance, we can use the dot predict, model.predict. So here specifically in our notebook, in my scripts that you see here, we will use the TensorFlow to create a multi-layer perceptron, you in for classifying the DZ. So if you have seen in the machine learning in one of the videos, we have worked on classifying the digits from the MNIST dataset. Okay, we'll be using the same MNIST modified National Institute of Standards and Technology database for handwritten digits for our this script using TensorFlow, and we will be mostly analyzing based on the multi-layer perceptron criteria. So first of all, for installation of TensorFlow, you need to follow this link. If you open it, it will take you through the link and um, how to install TensorFlow or choose the environment. All these things, all the links you could find up everything in here. So follow this link to install the TensorFlow. Now, first of all, before analyzing the data using TensorFlow, we need to first understand what is our data set. That is our MNIST data set. So, the version of the data set of MNIST that we will be using here, it will consist of 70,000 samples. So, total 70,000 samples are there, and each image is of 28 by 28 pixel images. This is the major structure of our dataset, MNIST. and it has more image than the scikit-learn. And rather than, if you have seen in the last videos using machine learning, you have seen that we have done the analysis using the 8 by 8 matrix or pixel matrix of data set deserts. But here rather we will consider more, highly resoluted data of 28 by 28. So, and the images are already separated into the training and testing sets. We don't have to be bothered about it. It's already split. Now, first let's see how to import the MNIST dataset, and then we will see how to load it. So don't get confused seeing all these warning signs here. So maybe I need to update it, so I have not done it. That's why I'm having this warning here. So probably if you are installing right now, if you have installed TensorFlow a Jupyter notebook lately, I mean just right now, then you probably would not be having this many warnings like I'm having right now. So let's see how to import the MNIST. So from this library tensorflow.keras.datasets, you need to import the dataset MNIST using the name. Now we will load the data, and by splitting them into the training sets and the testing sets. So once you run them, the data set will be loaded. Now after it's loaded, if you want to understand the data, what is the shape of the X, what is the shape of Y, so it will be accessed in this format. So we are mostly emphasizing on the training set. So use xtrain dot shape and ytrain dot shape. So if you see the xtrain dot shape, it has all total 60,000 of images, and each image is of 20 by 28 pixel values. And white train, how many samples it will have? It has, it will, the Y train shape will contain the target values basically. That is the target values, again having the same number as of the X train, and it contains the target values, that is the digits will be from 0 to 10. Okay, so once we get a detailed structure in our mind about this data, so let's see only first 10 images or 10 digits, and let's see how does it look like. So to get that, to plot it, you have to import the matplotlib.pyplot library as PLT. So using PLT, now you will call subplots function. So in order to have 3 rows and multiple columns like this, so in one plot you are having multiple subplots. To see that, in the subplots function you need to mention how many rows do you want and how many columns do you want. So if you see, there are 10 columns here and 3 rows, and the each figure size will be of 15 by 6. I'm not each figure, the whole figure, the plot of the figure will be, width will be 15 and height will be 6. Now all of those details will be assigned to the figure 1 object and access to another object. Now in order to lay out the images, so we have three parameters. So I have already written it: AX, image and number. So AX is for the layout of images. The image is for showing all the images like this. So each image contains the digit, how does it look like from the data set, and the number, which number does it correspond to. What is the extrain data, and what is the number. So that is specified by the image. And then the number, what it will have, the digits from the white trend set. So actually the digit, the number image is represented by your image variable, and the number is represented by the white trend target value here. For reference, you could follow this comment line that I have added. Now we don't want to see the axis at all, that's why I have set it to off. If you will show this one, that is to on, then you will have axis lines throughout our plot here. So I'm just putting it to off. Now to see the image, what color configuration that you want. So using this CMap variable value, we are showing our image using the IMShow function. Now to set title of each number, I mean if it's a digit, that is 5, the number 5 is to be represented in this way, number, then use the string function on the white trend value, that is our number. So it will be able to plot you the name, the number of the digit displayed accordingly. So now this is the structure. If once you run it, this will be the structure that you will get. Now let's see the next step in TensorFlow is to scale the data. So why do we scale the data? Actually, it often you have already set up the data set into Xtrend and YTrend, your training data set and the testing data set. Now to scale, if you scale the data, it will improve the performance of your neural network, and it will give you the better estimates for the weights and the bias terms. So from a basic input from one layer and then getting the proper output, you need to have some sort of bias and the weight values. So in order to get an appropriate value, we need to scale the data. And once we scale the data here in our particular example, each pixel will have now a value in between 0 and 1 just by default. So let's set a minimum value using the mean function on the xtrain and maximum on the using the max function. So in order to get the xtrain value, we need to use this value xtrain minus minimum divided by maximum minus minimum. So this is the way you need to scale the data, and for the X test as well. So once you run them, you will be able to get the scaled X train and X test values. If you want to see the values, try to just print them. Okay, X train and X test, just print them and see whatever values they are having. Now the next step after scaling is building your model. So to build the model, as I have explained earlier, we need to use the sequential function. Okay, here. So in order to do that, to first create the sequential model and then adding layers. So this is the first statement for creating the sequential model from the TensorFlow Keras models. We are importing it, and then to add the layers, okay, we are importing flatten, dense, conv 2D, max pooling 2D. So the first layer will flatten. Through the first layer will flatten each 28 by 20 image into a one-dimensional array containing this many number of pixel values, 784 pixel values. And with scikit-learn, actually the features usually have to have flattened prior, but with TensorFlow we can tell the model when to flatten the feature for us. Okay, so now after importing them, you need to call the sequential function and then build the model and store it in the object MLP. Now add layers using the flatten function. So the flatten function will actually flatten each 28 by 20 image into a one-dimensional array. Okay, so once you run it, the MLP will be created and then the layers will be added. The next thing to see, why is it 784 pixels? Because 20, once it flattened, it will give you a pixel value of 28 multiplied by 28, that is 784 pixel values of images. That is and all the images will be in the format of a one-dimensional array. Okay. Um, this is all about building the model. The next step is to um, dense layer. So there is a next step that we need to add the dense layer, which should contain at least 100 nodes. Okay, here we are using the add function and using this parameter. So every node in the previous layer is connected to each layer in the dense layer, and the dense layer will contain 100 nodes. So as you see, each of the 784 image features, that is the input nodes from the input layer, are connected to the newly created 100 nodes in the dense layer. So for each node, the sum of weighted inputs is transformed by this function, activation ReLU function. Okay, so by this, it will add the layers and will also connect the initial nodes to the dense layer 100 nodes. Then after that, what will happen? The node will output this transformed value, and when you run it, you will have this. I'm again also having this type of warning. You may not be able to see this warning in your own Jupyter notebook if you have installed it lately. And this ReLU function, what it does actually, this is called a rectified linear unit activation function. So, which has some properties that can enable more efficient training of our data set. Okay. So, through this add function, we are basically connecting the layers, providing the weighted inputs, sum of weighted inputs, and then creating the 100 nodes in the dense layer. Now the next thing, once we have set up the input layer, then dense layer, now next is to add our output layer. So in order to add the dense layer for our final output layer, the number of nodes in the output layer should be same as the number of target values. That is, we need the digits. How many number of digits? That is 10 digits, 0 to 9. Those pictures only we want to see. So for that, we are using the activation softmax function. So it will convert each output value to a probability so that the output sum to a 1, value of 1. So while making predictions, the target value corresponds to the node with the highest value. So a dense layer will be created with 10 nodes for our final last output layer, and we are using the soft max activation function in order to achieve that specification. Now let's say you want to see everything. How many layers do you have? How many nodes are there in each layer? Okay, to do that, use the summary function, and it will summarize our whole neural network that we have created through all the steps that I have just explained now. Okay, so remember that our if you once you run it, summary function, it will give you total number of parameters, trainable parameters, non-trainable parameters. So make sure, note that the neural network has this many number of total parameters which must be learned. Okay, and the none, here if you see these values, the none in the output shape, it will correspond to number of training samples which is not known in advance. Okay. So first, this is our first layer. So we are not aware about the output shapes. That's why it's showing none. And as there are 28 by 28, that is 784. So the image is flattened first in the first flatten function. So that's why it's showing this. And the dense function, we have created 100 nodes, and the next last layer that we have added here through the softmax activation function, it has 10 output nodes. That's why you have the shape of 10 here. As the output, we don't know the output shape in the advance, that's why it shows none here. I will make another one video for starting with compiling our model. So this is just whatever I have told you. These are the initial steps in our TensorFlow. I'll make another one video for the next compilation, starting with compilation.